Welcome to homework.
Okay, we've got to look at an energy diagram, which relates the relative energy to the dihedral angle regarding a Newman projection for 1,2-dichloroethane. So let's just start with the Newman projection of dichloroethane, which shows the lowest possible energy, right? So we know that at 180 degrees, that this graph has a minimum. So that's what we can use to kind of ground ourselves. Which Newman projection of 1,2-dichloroethane would have the lowest relative energy? That would be the one in which the chlorines are furthest apart. So we'll start with our circle there. Say, let's put a chlorine at the bottom, hydrogen here, hydrogen there. We've got our chlorine in the back as far away as it can be. Sorry, our chlorine in the front as far away as it can be from the chlorine on carbon 2, and a hydrogen here and a hydrogen here, right? So the 180 degrees is referring to the fact that these chlorines are 180 degrees from each other. Perfect. Now what they're asking is which of the Newman projections could be placed on this curve at either 60 or 300. So here or here. Now, what this also means is that the Newman projection that could be placed at 60 or 300 would represent a rotation of one of these, as in perhaps the front set of carbons, by 120 degrees, because 180 minus 120 equals 60, or 180 plus 120 equals 300. So if we rotate this clockwise by 120 degrees, what we would see then is the following. Chlorine in the back will be in the same location. Chlorine there. Right, this one's in the front. Oh, I forgot to rotate it. Let's try that again. Okay, so if we rotate 120 degrees, the chlorine will be on the lower right, hydrogen here, and hydrogen there. That would represent a 120 degree clockwise rotation. What if we did counterclockwise? Back chlorine would be in the same location. Hydrogen here, and now for the front, I have a chlorine here, and a hydrogen here. So what we've noticed now is that we've got 60 degrees between these chlorines in either case. Now, a valid way of drawing this Newman projection, I would point out, could also be like this. In that if we rotate everything, not just the front, but if we rotate the front and the back, for example, we could find that we have a Newman projection. Let's put a chlorine here, hydrogen here, and then for the front, we could put a chlorine here, hydrogen here, and here. So this Newman projection would be equivalent to the two I've drawn that I'm currently boxing, right? So all we need to find is a Newman projection where the two chlorines are what's called gauche to each other, or right next to each other. Any Newman projection that shows the chlorines 60 degrees from each other or neighboring each other would correspond then to either of these dihedral angle points in terms of energy. And if we look at the graph, or if we look at the options shown, there is indeed a Newman projection, number 4. chlorine there, hydrogen here, that's the front, and in the back, chlorine is down, hydrogen like that, and hydrogen like that. 60 degrees from each other.